All right, here we're looking at a three-particle problem, and we're trying to determine the force on particle B. Actually, the acceleration of particle B. So we want to know A sub B. And to do that, we've got to find the force. Okay? So, based on Coulomb's force, any two charged objects exert a force on each other. In this case, there are three charged objects, though. So we have to consider both the force from A on B and the force from C on B. So Coulomb's law tells us that it's going to be K Q1 Q2 over R squared. In this case, that's 8.99 times 10 to the negative 9th. Or 10 to the 9th, sorry, not negative 9th, 10 to the 9th. Okay? That times, okay, the charge of A, negative 30 times 10 to the negative 6th, times charge of B, 20 times 10 to the negative 6th, all over 0.8 squared. This should come out to be 8.43 newtons. Alright, we look for F. Force C on B, we get much the same setup, except it's 8.99 times 10 to the 9th. Okay, which should be negative here. Times 20 times 10 to the negative 6 times 10 times 10 to the negative 6th, all over 1.1 squared. And that comes out to be 1.49 newtons. Now, since these are both forces on B, we have to combine them to get the total force, because we know that AB equals the force on B over B's mass. So the question is, how do we combine these two? Are we going to add them, or are they going to be subtracted? Well, so let's consider direction. This first force from A and B, one's negative, one's positive. So what kind of force are we going to get? It's attractive, which means that the force is going to pull in this direction. Between B and C, they're both the same, which means we get a pushing force, which means that that's also going to be pointed in this direction. So because they're pointed in the same direction, we have to add them. Okay, we add them together, and we get 9.92 newtons, which then divided by 0.2, acceleration equals 49.6 meters per second squared to the left. And that is the acceleration.